Hi everyone, my name is Kim Sparling and I'm Vice President of Product for SAILDRONE. Today I'll be giving an introduction to SAILDRONE Uncrewed Surface Vehicles, or USVs. I'll start out by giving an overview of our organization, the technology itself, and approaches we've taken to date when working with established data centers. Finally, I'll touch on opportunities for future developments and ways that this international ocean data community can work with us to maximize the utility of the continually growing catalog of data sets that we produce. SAILDRONE is a small business headquartered in Alameda, California. You can see here our facility, which is in the Bay Area, is where we design and manufacture our fleet of USVs. Unlike many other USV companies, we typically do not sell the platforms themselves. Instead, we operate them for our customers and partners in what we call a mission-as-a-service model. We have platform operators who sail and monitor the health and safety of the USVs. They're typically monitoring for navigational hazards, but also have sailing experience to optimize the sailing and performance of these vehicles to meet the science objectives laid out by our partners. In addition to expert pilots, our mission-as-a-service model includes software systems and data flows that we've built out in order to manage and deliver the data associated with a mission. In working with a diverse set of partners globally, we've had the opportunity to sail our USVs in most of the world's oceans to collect a variety of unique data sets. You can see some examples here of the missions that we've performed over the years and the diversity of geographies and conditions that we've dealt with. Anywhere from rough seas and icebergs when circumnavigating Antarctica to becalmed waters at the equator near the Parada and Tau arrays. All of these missions were performed with our Explorer platform, which have amounted to over 500,000 nautical miles sailed in over 40 years at sea. We've been working to standardize the type and location of sensors, and so far we've narrowed down the list to what you can see here for our Explorer platform. While we do have a lot of experience on the engineering and operations front, we typically rely on our partners for data quality both upstream on the selection of sensors and downstream on the analysis of collected data sets. In terms of the data we're collecting from those sensors, there are two main data flows. Near real-time data, which is transmitted via satellite, and delayed mode data, which is recovered at the end of the mission. For both data flows, we try to leverage as much of the same infrastructure as possible. The same cloud environment, centralized metadata stores, and a series of microservices to transform and export the data into different file formats, like CF-compliant NetCDF files. When it comes to our near real-time data products, as I mentioned before, we're relying on satellite communications to transmit downsampled data. This is typically time-averaged means of the different sensor payload parameters. The frequency that we receive this data is often limited by available power on board the USV, but on average, it's a data point every 15 to 30 minutes, and then a large batch of 1-minute data that gets received every hour. As soon as we receive the data via SATCOM, we make it available to downstream clients like our mission portal, and it's also immediately available in a RESTful API, which many of our users use to integrate the data into their own applications, and you can see a couple of those here. In addition to the near real-time API, we package up the average data into CF-compliant NetCDF files. The frequency of export can range anywhere from every 2 hours to every 24 hours, and is highly dependent on what the use case is for the data. For example, we've been partnering with NOAA PML to get SAILDRONE data into the hands of weather forecasters through the OpenGTS project. In this workflow, we automatically export NetCDF files every 2 hours and export them to an FTP server. From there, parameters like wind speed, pressure, temperature, and other variables relevant for forecasters are made available via AirDAP and then pushed to the GTS. Ultimately, we aspire to send as much data as possible to shore while the drones are deployed so that we can maximize the utility of the data. So we're working on different strategies that would allow either more frequent or higher resolution data transfers in near real time. The sensors are all logging higher resolution data on board the drones, typically at 1 Hz or 20 Hz. As I mentioned before, this data is offboarded from the drone when it's completed its mission and the USV has been recovered. Ultimately, we export this data into NetCDF files and share those with our partners. It's typically up to the funders of a mission to specify the ultimate place they'd like to see the data archived. For many missions, this ends up being data archive centers like NOAA NCEI, NASA's Physical Oceanographic DAC or PODAC, or EMODNet. In 2019, we started to build out our own data explorer site, data.saildrone.com. While it's not a formal data archive, we hope that it does make it easier to find a consolidated list of SAILDRONE datasets that are freely accessible to access and download, while also giving some insight into the geographies we've operated in. It's a site that we're inevitably hoping to continue to grow and improve upon moving forward as a catalog that complements and links out to other hosted partner archives. While the systems I've covered so far have served us well historically, there are a few areas that I just wanted to call out for this community as points of consideration and potential areas for future collaboration. The first area is platform classification. Since USVs are a relatively new type of platform in the ocean observing space, there's still some room for developing clearer vocabularies and classifications for USVs. It's not uncommon for us to be grouped with drifting buoys or floats, or sometimes categorized as ships or vessels. The risk of being miscategorized could mean that the data we're collecting and disseminating gets excluded or blacklisted further downstream. Further familiarization and socialization of this new classification will potentially help the ocean data community leverage and use a growing new type of data set. The second area is data quality. Historically, we've relied on our science partners, who we consider to be subject matter experts in various sensor data, to perform and maintain data quality checks and procedures. This has worked well when the scale of data is relatively small, but as we continue to grow, this is an area we'd like to automate and leverage existing frameworks that are used within the community already. Knowing the right conventions to follow, how to incorporate these checks and flags into our data, and also extending them into this new type of platform is something that we'd really like to invest in and could benefit from guidance and input from this community on. The final area I'd like to call out for this group is a way to continually improve distribution flows into operational data centers and ultimately into the hands of data consumers. In general, as a commercial organization, it's not always clear what pathways exist and are supported to get data into models and analyses that could benefit from more observations. Making those pathways and centers more clearly documented and accessible would help increase data accessibility. On a related note, even just understanding how to register or get unique platform codes or IDs that correspond with the appropriate platform class would be a step in the right direction. Thank you all for listening to my presentation. I look forward to continuing to work with the international ocean data community. For any further questions, please feel free to reach out to me via email.